Hello everyone. Welcome to the last task of week 6, that is task number 30. This is also a very important question for your examinations. Basically, in this particular type of program, here you will be given different types of sequences, and you have to identify the pattern in the sequence, and you have to implement the pattern visually. Okay, so in this case you will have to print a pattern something like this, right? And this value of n, that means to which the value you have to compute, will be decided by the user. Okay, so the user enters the value of n. Okay, I will just show you the sample of how the program looks. So if the user enters the value of n as 6, then there it should go up till 2 raised to 6, right? Okay, so so this is how it looks. And it as the program says, you also have to compute the value of the series. Okay, so basically it's like calculating what is this output of this result. Okay, so let's try to find the solution to this particular problem. Okay, so let's begin by declaring the variables that we require. So to store the value of n, we will be requiring uh, an integer value, right? Then since we have to find out the values of the series, we need to run a for loop, and for the for loop we will be needing a counter variable. Let's define it as I. Okay, and then finally let's we also have to compute the value of the series. Let that be equal to a sum. Okay, now since they are going to be fractions, it is better we have the sum stored in float. Okay, so let's take a float variable, let's call it as sum. Okay, and let's initialize it for the time being with 0. Okay, so let's start the sum value with 0. Okay, and we will see later that we will have to change it to some other value. Okay, let's go ahead. First let's print the purpose of this program. Okay, so let us call this as series printer. Okay, then after that we can take the input scanf with the help of percentage %d and ampersand sign n, and we would also like to tell the user as to what this uh, value that they have to enter. Okay, so enter n, and then they enter the value of n, and then we can start with the for loop. Right now, when I start with the for loop, now look at this pattern over here. Now these patterns, they all look the same, right? So it is 1 divided by 2, 1 divided by 4, 1, and only the first term is looks a bit different, right? So what we are going to do is, since the first term is going to be fixed always, we are going to print it directly. We are going to print the first term directly. Okay, that we are not going to take inside our loop. Okay, now we will start with a for loop. Okay, and inside of for loop our counter variable is I will start from value of 1. Okay, why value of 1? Because the first value is 2 raised to 1, right? 2 raised to 1 is 2, then 2 raised to 2 is 4, 2 raised to 3 is 8, right? So our terms start from 1 to n, right? So that's why, so this is the for loop on which this is the part on which we are going to implement the for loop. Okay, since 1 we have already printed, right? So we are going to start from 1 till I is less than equal to n. Okay, because we have to reach till n, that's why we have put less than equal to. Okay, Then I have to increment I because I'm starting from 1 and go up till n. Once this is done, my next step would be to simply print uh, the sequence one by one, right? So I will simply do printf, right? And inside the printf, let us see in the series what is left, right? So we have already printf 1 and the space, right? So 1 and a space is printed, right? Then what is left is plus sign and the term, right? So this term is a single term. This will be divided into single term. Then in the next iteration this term will be printed, this plus sign and 1 by 4. In the next iteration plus sign and 1 by 8, right? So our printf should start with a plus sign, right? Then 1 divide by, and this value that is going to be here, that depends on I, right? So I will simply do percentage %d, right? And then I will use the power function to find out the uh, value of this value, that is 2 raised to I, right? So I'm going to find with the help of power. So if you see, I have already included the math library, right? So I can simply say to the base 2 raised to I, right? So now what happens is it is going to print this value, right? It is going to calculate power 2 raised to I, and it is going to print over here, but I have written here as percentage %d. Okay, now since all the functions of the math library handles only double, so I will have to typecast this into an integer to make this work, right? So now this value becomes an integer, so now it can be printed over here. Okay, so I think this much we will test and then go ahead with the sum of the series. Okay, so let's put a value of 5 and you can see we get the result perfectly, but you can see the a little bit of space would be better over here so that it looks better, right? So if I add okay, perfect. Okay, so now the series looks perfect. Now only thing left is to find out the value of this series, right? Now to find the value of the series, you can see we have already declared a variable called sum, right? So as soon as we find out the value, as soon as we run the particular iteration, we should also calculate the sum, right? So to calculate the sum, we will simply write sum is equal to sum plus, then this formula has to be implemented, right? So plus divide by the value of this data, right? So I will simply do 1 divide by this term, right? And then I will close this. Okay, and once all the iterations are done, the sum will be populated, then I am able to I'm ready to print the value of sum. Okay, so I can simply do sum equal to percentage f because it is float, right? So after doing percentage f, I can simply do sum. Okay, and if I do plus if I do try to run this, and with 6 you can see I'm getting 0.000, right? Now why am I getting this is because if you look at this you have converted into int, right? Because of this typecasting, and this is already an int, right? So what is the value of an integer divided by integer? It has to be an integer, right? And if you recall, this value is always higher than 1, right? So whenever you divide, you will get something in the range 0 point something something, right? So if it's an integer, then this will be approximated to 0, right? So there are two ways of handling it. First way is just don't cast it here. Okay, we casted it here because we wanted to print %d. Okay, that is one way of doing it. Or second way is just convert this into float. Okay, so we will try this method. Okay, we will not cast it, right? So I will enter the term 6 and you can see we get the value of the series 0.198. Okay, so this is not the correct value because we have missed one thing. Let me just show you what I mean. Okay, so I will just enter the value of 1 over here, right? And if you see what is the value of this series, right? So this is much easier to compute, that's why I have taken this value. It is 1 plus half, right? Half is 0.5, and if you look at this is only calculating this particular half, so it has skipped this one, right? The reason is because it is starting the sum value from 0, right? But whereas if you look at the pattern, the starting value was initial value of the sum was 1. Okay, we started the pattern for this, right? The remaining sequences, so the starting value of the sum should have been 1. So that's why at the beginning I said this had to be changed later, right? So the starting value of the sum should have been 1. Okay, so now if I try to run it again, you will get the correct answer. Okay, so let's take series of 1 and you get perfect answer 1.5. Okay, so now if you run again for the element 6, then you can see this is the result that you get. Okay, so I hope you have understood this particular example. So this finishes with the for loop of this week. Next week we will start with while and do while loop. See you in the next week.